So the place is ready and we are waiting 1 more minute to see if that last person is going to show up. We are missing still 3 students. Yeah. And so, oh, by the way, that's my grandma there. She died when I was maybe 5 years old. So all I know from her is this picture. And this is the road that goes next to my house in the village. Such a nice road. I'm missing it. So. But I miss it less when you guys come to class like this. So. Do you guys have any questions for me before we start the lecture today? No? Oh, see, do you see my eyebrows moving? Man, this class is so calm that I'm thinking I'm alone here. Oh. Okay, we got one more. Missing still 2. See? All right, if you guys don't like my face, let me just put the notes now. Maybe that one will get you guys fired. All right, so we're gonna do differential equations, and the topic will be an update of what we had at the end of the previous lecture, which is linear equations with fixed coefficients. And that is, of course, homogeneous. Last time we talked about second order equations. Today we will talk about equations of order larger than 2. Now let's start by this problem. Example 1 for today. Let's say we have a problem that says we have this minus, I don't know if that was 16. Yes, it is 16. Y prime equals 0. So fifth derivative minus 16 times the first derivative equals 0. That's fifth derivative. Now in this example, I'm going to show you how you handle the problem when you have an order more than 3, more than 2. So first thing, you write down the Euler equation as usual, turning derivatives into powers of lambda. So here it's lambda to the fifth, because for fifth derivative, minus 16 lambda to the power 1, because first derivative, equals 0. Nothing else over here. All right. Now, when you have such an equation, what you need to know is you must have as many solutions as the order of the equation. So that's power 5. That's the order. So you must have 5 solutions. If you solve that and you don't see 5 solutions, then you messed up somewhere. How do you solve it? Now my answer is, man, those are your skills of algebra. You know, you got to handle your algebra, make sure you get them all. And this one, I'm going to factor out lambda because I see a common factor, lambda. This doesn't mean that anytime you see a problem, you factor out lambda. You can only factor out lambda if it can. Because lambda is here, I can factor that out. If there was a constant here, then I wouldn't be able to factor out lambda because there is a constant. So right now, I'm putting lambda on the side. So here I remain with lambda to the fourth minus 16 equals 0. Okay? Now, next thing is I can continue to factor out this thing. This is like a squared minus b squared. So that's right here, lambda squared minus 4 squared. That's what you have there, which is a squared minus b squared. In algebra, you learned that a squared minus b squared is a minus b times a plus b. So that's what you're going to have here. Lambda squared plus 4 times lambda squared minus 4 equals 0. And then here I can see again that I can factor this piece out because this is again lambda squared minus 2 squared. So that's lambda times lambda squared plus 4 times lambda minus 2 times lambda plus 2 equals 0. I can't do anything to this one because lambda squared plus 4, you can't solve that in real numbers. So it's going to give you the complex conjugate roots. Have I seen Trevor here?
You asked about me?
Oh yeah, I didn't see you, so I was asking if you were in.
You can't see me like with the video. I got
Oh,
the video on.
I'll get that. Yeah, I see you now. It was on the other page because many people are in it, and you probably got in later than some people, and then it pushed you very far away. So I was trying to ask a question, and I wasn't seeing that you were there. So here, this is the question that you asked me last time. That's why I thought of you. Okay. So when you get lambda squared plus 4, then you know you're going to have complex conjugate numbers there because that plus 4 is going to bring in I. And so here, the first one is lambda 1 equals 0. Lambda 2, 3 for this pair is going to be plus minus 2I. Because when I want to solve this equals 0, I get lambda squared equal minus 4. That's why I get plus minus square root of 4 plus minus square root of negative 4, and that is 2, and I for square root of negative 1. And this one is going to give you lambda 4 equal 2, and then lambda 5 equal minus 2. And you can see that we got 5 roots. Now, how do you write the answer when you get to this level? You use the rules that we had down for second order equations. When a root is by itself, you just use e to lambda x. When you have a root that repeats, you have e to lambda x plus x and then e again. When you have complex conjugate roots, you know you have e to the alpha x cosine and then e to the alpha x sine. So that's the rule in general. So here you are going to have y of x equals c1. This root is a simple root by itself. So that's e to the 0x plus this is two complex conjugate roots. So that is going to be c2 e to the, and alpha here is 0. So alpha is 0, that's 0x. Cosine beta is 2x plus c3 e to the 0x for alpha, sine of 2x for beta. And then lambda 4, that's a simple root, that's c4 e to the 2x. And lambda 5 is a simple root, that's c5 e to the minus 2x. And now you can simplify this. This is c1 plus c2 cosine 2x plus c3 sine 2x plus c4 e to the 2x plus c5 e to minus 2x. And so this is the general solution of the original equation. And again, what are the rules? One, for a simple root. A simple root meaning for a simple, say, real root. It's real, it's simple, meaning that it doesn't repeat. So it's a root that comes one time. Use the constant times e to the lambda x. That's one. You have a simple root, it gives you one piece like that in the solution. So for a root, so let's say for a double root, double real root, because you can have a double that is not real as well. You're gonna use c1 e to the lambda x plus c2x e to the lambda x. So if the root lambda comes twice, it's going to give you this piece of the general solution. If it comes one time, it's just this. Two times the same root, it is this. If in general, you have a root of multiplicity m, which means that that root comes m times, then you are going to have c1 e to the lambda x. Notice that for a double root, you got c1, c2. So for a root of multiplicity m, you are going to have m c's. So that'll be c1 plus c2x e to the lambda x plus till you get to cm x to the power m minus 1 e to the lambda x. So you are going to add the terms all the way up to x to the power m minus 1 times e to the lambda x. And then you can prove that this is a solution of that. We don't need to do that at this point, because what we need to do is to learn how to use that. Okay. Am I making sense with this notation? Hello?
Yes.
In this case, m was 2. So we got all the way to c. M is 2. So that's c2. X to the power 2 minus 1 is 1. That's this. All right. And you will add everything inside there. Now, for complex conjugate roots, alpha plus minus I beta, then you are going to have the piece c1 e to the alpha x cosine of beta x plus c2 e to the alpha x sine of beta x. So these are the different options that you have. When you have order higher than 2, you can have many roots that in the end will be used in this way. In the example that we had one, what have case one in 1, 2, 3 pieces. We didn't have case two. We had case three. Nope, we didn't. We had case four. Yes. What is this piece? And so today, what we are going to do will be work out some examples on how to use these cases while solving problems. So the first difficult thing is be able to properly solve the Euler equation. And after that, being able to write this general solution using the appropriate rules from here. Is there any question about this? All right, so let's look at another example and give you a crazy example here that sometimes I like too much. Let's say we have an example, 6 derivative equals 0. Can you tell me what's the Euler equation here?
Lambda to the 6.
Yeah, and then something is missing. Lambda to the 6
Equals 0.
equals 0. So solve it. What's the solution? Want to try, Charlie?
I think I'll pass for now. That's all right.
And I just call it because you're sitting next to Charlie, who is sitting next to Trevor. So do you want to say what the solution of this is? Is she with me?
Is lambda just 0?
I call Anne.
Trevor can do it. He can take it.
What's that?
Trevor can take it.
I went from Trevor to Charlie, then to you.
Yeah, I'm not. I don't have it yet.
All right, James.
Could lambda be 0? Just 0? Is it just 0?
Man, you gotta tell me what the answer is. You're kind of asking me if it is the answer. You're not telling me it is the answer, right?
I don't know.
So I'm hoping you guys solve it. It's just as is. It is what it is. Lambda to the power 6 equals 0. What are the answers? And the rule is the number of answers must be equal to the order of the equation. That's what I tell you. So how many answers do I have here?
6.
6. And what are the 6 answers?
I guess all 6 of them 0.
That's it, man. You don't doubt yourself. That's it. There are 6 answers. They are all zeros. So you got lambda 1 equal lambda 2 equal lambda 3 lambda 4 equal lambda 5 equal lambda 6, and they are all zeros. So 0 is a root of multiplicity 6. That's what it means. So m in this problem is 6. Therefore, your answer is going to be y of x equals c1 e to the 0x plus c2 according to that x e to the 0x plus c3 x squared e to the 0x plus c4 x cubed e to the 0x plus c5 x to the 4th e to the 0x plus c6 x to the 5th e to the 0x. That's what that formula says. And now you are going to head in there and simplify this thing. So that tells you y of x equal e to the 0x is 1. So this is c1 plus c2x plus c3x squared plus c4x cubed plus c6x to the power 5. So that's the answer. And technically what this means is that this here is all the functions whose sixth derivative is equal to 0.
Did you forget the C5?
I turn 5 into 6, c5x to the 4th, c6x to the 5th. Thank you. So c1 plus c2 plus c3, c4, c5, c6. Now, usually the mistake that we have from students is that you don't look carefully what the answer is here, and when the time comes, you write for me c1 plus c2 plus c3 plus c4 plus c5 plus c6 is the answer. No powers of x. And what you forget is the sum of all those c's is just one fat big C. So you wrote one solution, one of the 6. So you don't have it. So it should be C1, C2x, C3x squared, C4x cubed, C5x to the 4th, C6x to the 5th, as the formula says. And again, you can check if we actually take this derivative. This is a simple example on which you can understand why this answer is okay. You can take this 6th derivative and then integrate step by step. You will see that you recover this function, that this is the set of all solutions. You can integrate step by step. If you integrate one time, you will get the 5th derivative is a constant. You integrate again until you get y of x equal to this. Okay. Is there any question? All right. Is there anybody angry? Anybody happy? Now let me ask the other question. Is everybody happy?
Yes.
Yeah, man, I know you're happy, Trevor. I'm happy that you're happy. I don't know if James is happy. He doesn't talk. Are you there, James?
Yes, sir, I am.
You fine? You don't know yet?
I understand the last one now. I just couldn't figure it out at the time.
That's fine. I'm just calling across to see, make sure that we are on the same page, because this is the right time to figure it out. Because if we miss it now, then next week it would just look like Chinese for me, which is something that I don't know. Or like my grandma used to say, just look at it as when a dog is watching TV. He can't really understand what's going on. The only time you know that it's feeling something is like the tail is shaking. Right. All right, so if this is all fine, then let us together look at the next example. And I'm going to give you guys some minutes to work on it before I show the answer. All right, so we go example 3. And that example 3 is going to be, we say 16. 16. And then fourth derivative plus 24 second derivative plus 9 y equals 0. And that's a smiling 0. All right, so I let you guys look at this. 5 minutes, write down the Euler equation. Let us first write the Euler equation together so that you guys just take time to solve it. So what's the Euler equation here? Dakota?
16 lambda to the fourth.
Yep.
Plus 24 lambda to the square.
Yep.
Plus 9 lambda. Or
just 9 because you don't have a derivative here, right?
Right.
And this is the point where we will have the most problems, knowing that this guy doesn't come with a lambda, because once you miss that, the rest is gone. In some problems, it ends with prime, and therefore you need to put lambda. But when it ends with y, make sure you don't have lambda where you just have y, because here derivative is 0, so it's lambda to the power 0, so it's just y. So this is the Euler equation. Now you guys solve it for me, please. Let me see. First one gets to tell us what the lambdas are. So who has something to show? Carson?
Not yet.
Not yet? Okay. I have Ryan. Is Ryan ready here? Ryan Crosby. Apparently he's not on the set. Michael Hill. Michael Payne.
Yeah, I'm here.
Yep, can I have your answer?
I haven't figured it out yet.
Joseph.
Still working on it.
William. Elrod.
I'm also still working on it. It's not going well right now.
That's a quadratic equation. That's a hint.
Okay, that does help.
Have something, Ethan?
No, sir.
Yeah. Mr. Cooper.
I thought I was on something, but once you said it was a quadratic, I knew I had messed up.
All right, just modify.
I'm also still working on finding my answer.
I think I know what it is.
Yep, I'm listening.
All right, so you can factor out that quadratic into 4 lambda squared plus 3 and 4 lambda squared plus 3.
That's fantastic.
You would then solve lambda for plus or minus I square root of 3 over 2.
So you get lambda squared equals minus 3/4, right?
Yes.
And this is twice because of this square. Does that make sense? So each of the roots is repeated. Now, how do we solve this one? It's what we had in the previous problem. It's lambda is plus minus square root of negative 3/4. And what is this?
I square root of 3 over 4, or square root of 3 over 2.
Yep, that's it. So that's the answer. Thank you very much. So we got twice root 3 over 2i, and we got twice negative root 3 over 2i. So if the answer was just this without the twice, then we would have y of x equals c1 e to the 0x, because alpha is 0. That's alpha here, 0, and this is beta, cosine root 3 over 2x plus c2 e to the 0x sine of root 3 over 2x. This is what we would have if it was just this answer. Now, because each of them is twice, we are actually going to add plus x times each of them. Does that make sense? So that's going to be c3x e to the 0x cosine of root 3 over 2x plus c4x e to the 0x sine of root 3 over 2x. So this and that because of twice. And you know it's a fourth order equation, fourth order, so your general solution must have 4 constants, right? The number of constants is always equal to the order of the equation. So perhaps here you understand that you're on the right path. If you don't have 4, then there is a problem. And so now you can check and compute all the necessary. E to the 0x is 1, so that's c1 cosine root 3 over 2x, c2 sine root 3 over 2x, c3x cosine root 3 over 2x, and then c4x sine root 3 over 2x. That's it. This is how you would solve the problem in this case. questions? So again, when the equation is of order higher, larger than 2, then you need to be very careful what are the tools that you use. First of all, we could do this way, the way he suggested, but we could also just see here that this is a quadratic and solve it as this is 16 x squared plus 24x plus 9 equals 0, where x is lambda squared. You could have that equation. This equation is exactly that. Okay? And when you want to solve that, then you get lambda, you get x 1, 2 equals minus b minus 24 plus minus square root of b squared 24 squared minus 4 times 16 times 9 divided by 2 times 16. And this thing here is 0. So you get that x 1, 2 equals minus 3/4. That's the same answer. That's the same answer we got here. And that's why it's written twice, because we got 2 equal solutions using the quadratic. And now you replace x by its value, which is lambda squared. So that's lambda squared equal negative 3/4. And then you continue the same way we did here. So 2 ways. Is there any question, please? No. Does this mean that I'm explaining this thing very well? I don't know, you guys are just gonna make me envy myself. Are we good, John? John, is he still here?
Yes.
Are we good? I was asking.
Oh, yes. So
All right, sorry. Now let me put another problem of the kind that I like the most. Third derivative. That's example 4. Third derivative plus 3 times the second derivative plus 3 times the derivative plus y equals 0. It's always equal to 0 in this class as of now. Now, what do you think? Of course, here, first thing to do is put down the Euler equation. So what do you think? I'm going to ask, Mr. Lynch, can you give me the Euler equation?
Yeah, it's going to be lambda cubed
Right.
plus 3 lambda squared
Excellent.
plus 3 lambda plus 1.
Plus 1. Great. Sometimes people do forget when there is no coefficient here, you just cancel this piece, but it's plus 1 because we got 1 in front of y. So that's plus 1 equals 0. So this is the Euler equation. As you can see, it's a third order equation that we need to solve. Your take on this? How are we going to solve this?
Do we start off by moving the 1 to the other side?
If you do that, you're gonna mess up your life on this one.
Isn't it just lambda plus 1 cubed?
That is it. It is lambda plus 1 cube. So it has to do a lot of with your skills and how quick you see the things. If you don't see that it's lambda plus 1 cube, there's a lot of work you're gonna do here to establish that that's actually lambda plus 1 cubed. Okay. But in the end, you will still end there that it is lambda plus 1 cubed. Because here, this is a plus b cubed is a cubed plus 3ab squared plus 3ba squared plus b cubed. That's how you get a plus b cubed. And then she looked at this and she sees, okay, b cubed is 1, so b is 1. And so that's plus 3 times 1 times lambda squared, 3 times 1 squared times lambda. So this is lambda plus 1 cubed. Because the whole thing is lambda plus 1 cubed equals 0. Now, if you don't see that, there's still something you can do. You need to make sure you can guess one of the answers. If you can guess one of the answers, then you can use it to factor out the whole thing, and then your life will be easier from that point. So here, if I didn't see that, so this is going to give me lambda 1 equal lambda 2 equal lambda 3 equal negative 1. So it's a triple root here, the same root that comes 3 times. Now let me show you here the other way. If you just look at this and you don't see that it's lambda plus 1 cubed, you are going to try to factor it out somehow. You want to try to factor it out somehow. And before you do so, you need to make sure you figure out one number perhaps that makes this thing 0 by trial and error, trying some of the few numbers. And the easy number to always try, like 1, negative 1, 2, negative 2, and so on. So here, and you see negative 1, you can see negative 1 cubed, that's negative 1, plus 3, minus 3, plus 1 equals 0. So minus 1 is a root. And if I see that minus 1 is a root, then I am going to try to factor out the term that gets solved by minus 1. And that term is lambda plus 1. So I'm going to try to factor out lambda plus 1 from this whole thing. How is that done? Please follow me carefully here. In this problem, it was easy to see that it's lambda plus 1 cubed equals 0, but in another problem, it might not be that easy, but you can still be able to figure one root. And if you can figure one root, how do you use it to help? Right here, I'm saying you want to factor out lambda plus 1 because you already know that minus 1 is a root. So you want to factor out lambda plus 1. I say, look at this thing and group the terms 2 by 2 starting from the left, making sure that from each of them you can factor out lambda plus 1. So I'm going to group terms 2 by 2 starting by lambda cube, then following with lambda squared, but making sure I can factor out lambda plus 1. Therefore, what is the term I need here? That's lambda squared. From this, I can factor out lambda plus 1. Now, I was moving on, but I took only lambda squared, but there were 3 lambda squared. So I remain with 2 lambda squared. Am I making sense? It's better you follow me and not write anything, but understand what I'm doing instead of trying to write when I'm doing and not understand what's going on. So there were 3 lambda squared. I got 1 here to make sure that I can factor out lambda plus 1. And I remain with 2 lambda squared. And my goal from the beginning was group terms 2 by 2. So I'm going to head to the next term and I'm going to take enough of it to add here to make sure I can factor out lambda plus 1. That is 2 lambda. If I have 2 lambda here, then I can factor out lambda plus 1 from this as well. Therefore, I got 2 lambdas. There were 3, so I remain with 1 lambda. And then I get that last number 1, and you can see that the remainder is also something from which I can factor out lambda plus 1. Do you see that? So no matter what is the rule that you guess, if you do this, it's always going to work. From here, I get lambda plus 1. From here, I get another lambda plus 1. From here, I get lambda plus 1. So I factor out the lambda plus 1. When I factor out lambda plus 1 from the first block, I get lambda squared. From the second block, I get 2 lambda. And from the third block, I get 1. If I remove lambda plus 1, it's 1 I get it. Equals 0. You can see that though the thing factored out. And then you can see that what is inside here is nothing but lambda plus 1 squared, right? So that's the thing. That's how you would do in general. So that gives you lambda plus 1 cube, which takes you back there. Again, I said this method would work no matter what is the degree of that equation. And you know one solution, you group them 2 by 2 like this, you're going to be able to factor it out and perhaps reduce the problem to a smaller one. Now, how do we write the answer here? What is y of x for this one? Mason?
Why don't you use the root of multiplicity m, so it would be c1 e to the 0x. Or wait, no, would it be negative? No, it'd be 0x.
What is lambda?
-1. Okay, it's -1. And
Yep.
then plus c2x e to the -1 plus c3x squared e to the -x.
That's it. And you must have 3 constants because the equation is of third order. And then multiply by x and x squared because you got multiplicity 3. That's it. Perfect. Thank you. Any questions? And again, it's very important what we are doing now because the topics that we will be covering for test 3 are highly related to this. So if you don't understand this, then you miss test 2 and you miss test 3. So I'm spending the whole lecture on it after the half of the previous lecture because it is very important. Make sure you get it. Make sure you know how to write the solution, because if you can't, then you're stuck for half of the rest of the class, at least. All right, next example. And I'm gonna let you guys do this one. Let's say we have third derivative minus twice the second derivative So this is just minus the second derivative minus 4 times the function equals 0. Okay.
This might be a little bit of a guess, but could you let that factor out to be lambda minus 2 cubed?
Now, first of all, let us write down the Euler equation. What is it?
Lambda cubed minus 2 lambda squared.
Oh, there's no 2 here. It's just minus.
I don't know why I wrote 2.
Yeah, I had a 2 there, but then I had to cancel because with that 2 there, it changes what I was trying to give.
Oh, well, yeah, my thought was just.
So this is the equation that we have. And then I will actually add y of 0 equals 0, y prime of 0 equal 1. And the first thing I'll ask you to do here, can anyone here guess one of the answers? Because our success in this problem relies on our ability to guess one of the answers. If you can't guess one of the answers, then it's just no way you're gonna answer it.
Lambda equals 2.
Yep, you can guess 2. Now 2 cubed, that's 8 minus 4 minus 4, 0. Yes, so you got 1. You got the good guess. And so now if you guess 2, you try to factor out lambda minus 2. So from this thing, because it's not a quadratic equation, so you can't just use the quadratic on it. So now you try to factor out here lambda minus 2, applying this rule that I had here. Group terms 2 by 2, starting from the left, making sure that from each of the blocks you can factor out lambda minus 2. So do we have someone who successfully factored it out?
I got lambda minus 2.
You can show step by step how you group them here.
Oh, I did long division.
Yeah, that's also a good way to do. You can do long division as well.
Okay,
If you
that's what I did, and then I did long division with lambda minus 2.
Mm-hmm.
I came out with lambda squared plus lambda plus 2.
Plus 2. Okay. So now that's what you got. And now let me then show the other way around, but this is okay. So we could take lambda cubed minus 2 lambda squared, group them. Now, if I get minus 2 lambda squared and all I had was minus lambda squared in the equation, then I have to add another lambda squared to make sure that in total I have exactly what was there. So that's lambda squared. And then I bring in the lambdas, so that's minus 2 lambda. These two I can factor lambda minus 2 from them. I had no lambda, I had to bring them in, so I add the 2 that I subtracted here, and then minus 4 that was there. And from these two, I can also factor out lambda minus 2. And so you can see that if I put lambda minus 2 out, I'm going to have here lambda squared plus lambda plus 2 equals 0, which is the same answer he just reported here. Are we good? So no matter what is the method that you pick to do that, you're going to end up with the same answer. And now, this tells me here, for this piece, I can use the quadratic formula to solve this piece. For this piece, I got lambda 1 equal to. For the other piece, I can use the quadratic formula, lambda 2, 3 equals minus 1 plus minus square root of b squared 1 minus 4 times 2 times 1, so that's minus 8 over 2, right? Everybody okay with that? So b squared 1 minus 4ac minus 4 times 2, 8. And so that gives you minus 1/2 plus minus, and then this is square root of 7, I square root of 7 over 2. So that's alpha, and that's beta. And the I comes because this is square root of minus 7. And now you can write your answer. Y of x equals, that's C1 e to the 2x plus C2 e to negative 1/2 x cosine root 7 over 2x plus C3 e to negative 1/2 x sine of root 7 over 2x. Then for the initial values that are given, you can plug in the values and solve for the constants. Any questions on this? Does it make sense?
Yeah, it makes sense.
All right. If people are still writing, we keep a minute to write down. All right, so one last problem. Let's say we have 6 derivative minus twice fifth derivative plus twice the fourth derivative equals 0. So what would be the Euler equation here?
Lambda to the sixth minus 2 lambda to the fifth plus 2 lambda to the fourth equals 0.
Perfect. Now, how do we go about solving this? Do I still have Trevor? How do we solve this one, Mike?
Can't you take out a lambda because they all have lambda?
What power of lambda?
You can take out lambda to the 4.
Lambda to the 4, that's correct. You factor it out, and then you're left with
Lambda squared minus lambda and nothing from the other one, just 2 at the end.
yeah, equals 0. That's it. So this gives you 4 solutions. Lambda 1, 2, 3, 4 equals 0. 4 lambdas as 0. And then what about the other piece? The other piece is a quadratic equation, so you can use the quadratic formula on it. Lambda 5, 6 equal minus 2, that's 2, plus minus square root of b squared, negative 2 squared is 4, minus 4 times 2 times 1, that's minus 8 over 2, and that is 2 plus minus 2i over 2, that is 1 plus minus I. So these are alpha equal 1, beta equal 1 for this one, and these are repeated roots. So John, how do we write the answer here? What's y of x equal to with these roots that we got? What's the question for John? How do we write the answer with these roots that we got?
I've got the first one, but I'm not sure about the square root.
We already have the roots, lambda 1, 2, 3, 4.
I've got the first one. I'm not sure about the 5, 6.
So what's the first one?
Lambda to the 1.
What?
Lambda 1.
No. These are the formulas to be used.
Okay, I've done this wrong then.
Cooper.
I'm actually having some trouble with my answer. I may take another minute.
I'm just
I have the answer.
asking to use the lambdas that I wrote here, which are already here, to tell me what the answer is supposed to be. Messi, yes?
Okay, so it would be y of x is equal to c1 e to the 0x plus c2 x e to the 0x plus c3 x squared e to the 0x plus c4 x cubed e to the 0x plus c5 e to the x.
How many zeros do you have?
Oh, I think I might have done too many zeros. Wait, 1, 2, 3, 4. 4? We have 4 zeros. So it'd be x cubed e to the 0x, right?
Cubed e to the 0x.
And then c5, and then e to the x because alpha is 1, cosine of x because beta is 1.
Correct.
And then plus c6 e to the x sine x.
Someone is really laughing a lot there, and that's kind of disturbing. And so here you can do the work out, and what you get? C1, C2x, C3x squared, C4x cubed, and then C5 e to the x cosine x, C6 e to the x sine x. That's it. Thank you very much to everybody for today, and I think we stop here. You have any questions? Let me know. You don't have. I see you on the review on Tuesday before the test on Thursday. Homework's due Sunday.
Thank you.
Welcome.
Have a great weekend.
Same to you. Boom, 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 boom. We are done.